Alright guys, yesterday we started exploring the normal distribution, and we started working with the standard normal distribution. And we talked yesterday, we said, well, to change normally distributed variables to standard normal distribution variables, we had to find and use what are called z-values or z-scores. Yesterday, I just gave you z-scores or z-values, said, here we go, let's find the areas. Now today, we're going to do more of an application situation where we're not just handed z-values. So to use our standard normal distribution curve, first of all, the variable has to be normally or approximately normally distributed. Now, for the level stats course that this is, you are always going to be told that information. So when you read through a problem, you will be told the variable is normally distributed or it's approximately normally distributed. There are ways to check for normality. There are. That's not something that we're going to go through and do. So you will be told the variable is normally distributed or approximately normally distributed. I know for some of you the challenge always is, well, I don't know when to do each thing. That's your cue. That's your cue that we have this type of question. It's going to tell you that. To change the variable to a standard normal distribution variable, the z-value formula is really simple, and actually we did see it in the first unit. You just take the specific value you're looking at, the specific data value, subtract the mean, and divide by the standard deviation. That's all you have to do to change it. So z, you can either say they're standard units, because we're working with the standard normal distribution, or sometimes they're referred to as z-values. Now, to be very honest, as we look at the application piece, we're not going to be doing a whole lot different than what we did yesterday. The big difference is we're not just going to be told, find the area between z is 1.2 and 1.75. We have to actually use the data and actually find those z-values. We have to change from a normally distributed variable to a standard normally distributed variable. So let's take a look. We have a certain group of people. The mean systolic blood pressure is 120 with a standard deviation of 8. And the variable is normally distributed. There's your key phrase right there. So how do I know when I'm going to use this particular idea? There's your phrase. The variable is normally distributed. Find the percent of individuals who have a blood pressure between 120 and 130. So the first thing we have to do is change our data values, our standard normal variables, our normally distributed variables into standard normally distributed variables by finding our z-values. So to find our first z-value, data value, which is 120, minus the mean, which is also 120, divided by the standard deviation, which in this case is 8. Now, I chose this example. This is one of the reasons why I chose this example, is because we do end up with a z-value of 0, and that is okay. That's absolutely fine to have a z-value of 0. That's okay. Let's get our other z-value. Data value minus mean divided by standard deviation. So now once we take our normally distributed variable and change it to our standard normally distributed variable by finding those z-values, now the question becomes exactly what we practiced yesterday. Exactly what we practiced. So we have two z-values. We want to find between them. So I have a z-value of 0. 0 is always at the middle. Positive 1.25. And we want shaded between. We want to find the area between those. Now I realize the question asks us to find the percent of individuals. Remember, those areas, we get them in decimal form, and then we can change them to percents. No extra work involved other than to move the decimal point. So take a minute, guys, and see if you want to stick with the table, if that's what you practiced yesterday, then take some time, find the areas in the table. Or if you want to play around with the calculator, play around with the calculator. Use this opportunity to practice and ask some questions. What you should come up with should be 39.44%. So if we look at the next piece of this, now we're looking at for individuals above 126. Step 1, data value minus mean divided by standard deviation. And we get 3/4. Label your picture. 0, guys, is always at the middle. 0.75 is positive, so it's going to be off to the right. And then if I want the area above, yesterday when we were doing these, we either were specifically told to the left or to the right, or we had a greater than or less than symbol. Now we might have some different phrases that we have to interpret. So if I want above 126, which way am I going to shade? We're going to go right. We're going to go right. So now, same thing at this point, we've gotten the new piece for today out of the way. So I want to give you a chance to go ahead and see if you can recall how to find that specific area. Again, table or calculator, right now you don't have to be set on your choice. You can play around with both today. You should come up with all right, and I've had people that have definitely jumped ahead of me. They're already on the third part, totally fine. Now on the third part though, sorry guys, being a little glitchy here. You always have to do value minus mean. I know so far we've had 0 for a z-value, we've had all positive z-values. You can definitely have, and we saw a bunch of them yesterday, you can have negative z-values. They're just to the left of the mean. So don't switch anything that you're doing. Always do your data value, your specific data value, minus your mean. If it ends up negative, that's fine. That z-value just falls to the left of the mean, which is in the middle. That's okay. So 124 minus 120 divided by 8. And we get a half. So negative 0.75. And then positive 1/2. And we want between those two. Now again, I want you to make sure that, again, table, calculator, whatever you like, this one should come out to be now, once you are okay with these three, in the upper right-hand corner of your sheet, I want you to go ahead and try out that example. Try out both parts. And in just a minute, after I make sure everybody's okay with these three, I will get the answers up for those. I want to kind of give you this little checkpoint before we go in reverse like we did at the end of class yesterday. Now, the examples you're currently trying, guys, all I'm going to do right now is I'm going to draw the picture, and I'm going to put up the correct area. That's not all there is to these questions, though, but I want to make sure everybody's okay with finding the areas and drawing the pictures. And then if you haven't figured out yet how this question is different, we're going to talk about it. So again, I'm just going to put up here what the picture should look like and what the areas are. So again, all I have up here at this time is the correct z-values, the correct picture, and the correct area. I do not have the final answer up here yet, so if you can get this far, then see if you can figure out how to finish off these questions. Alright, so let's talk about what makes this question different. I know for some of you, you're working through and think, Miss Golly, this is the same thing. I got those last three, so why are we doing 2 more questions just like them? Well, how they start is the exact same. We find our z-values, we shade our areas, we find the area. Now the last question, though, specifically said, find the percent of individuals. This question, though, is different. I actually want find the number of students. So I don't want the percent of students, I want the number. I don't want the probability that a student's going to score below 76. I want to know how many are going to do that. So take your, we can just leave it right as a decimal, because really it's a percent just in decimal form, and take it times your total number of students. So how many students are going to score below? We're going to have 3,085 students. So the big thing is, a lot of the process is going to be the same for these questions. You're going to change to z-values, you're going to find your area. From there, though, you have to make sure you've answered the question. Am I looking for a probability? Am I asked for a percent? Or am I asked for the number of people, or the number of light bulbs, or the number of cell phones, whatever you're dealing with? So you have to make sure you've answered the question completely. So same thing for the second part. Take your area times 10,000, 1,210 students. So just make sure you have fully answered the question, okay? Now, just like we did yesterday, taking things up, I would say, to the next level. Finding data values given specific probabilities or percentages. Now, I know you guys have the question on your sheet. This is number 26 in your books, if you want that reference. So if we take a look at what the question gives us in number 26, it says we have a mandatory competency test for high school sophomores. Has a normal distribution. There's your key word. If you want to underline it on yours, I know I don't have it up here. It didn't fit right on mine. So it has a normal distribution with a mean of 400 and a standard deviation of 100. The top 3 students, that's top 3% of students, receive $500. What's the minimum score you need to receive this award? So now we're given the percent, and we're told it's the top 3%. So what will that look like for us? Let's write down the information that we know for Part A. We know the mean is 400. We know the standard deviation is 100. We've got to figure out what the z is so we can figure out the x. The x is the score we're trying to find that we need to score above to get that scholarship or to get that award. So I'm writing down the things we know. We also know we're looking for the top 3%, so we can draw our picture. The top 3%, and we're just guesstimating here, we're trying to find the z that goes with it. The top 3% is just going to be that right tail And then the area of that is just going to be 3% written as a decimal. So I'm just jotting down and using the information that I'm given. I'm given the top 3%, so that's going to be just that far right tail. 3% changed to a decimal, 0.0300. I know my mean, I know my standard deviation, but that's all I know at this point. So what I want you to do, I'm going to give you the opportunity. This is something we practiced towards the end of yesterday. Take the opportunity, see if you can figure out, if you're given that percent, aka that area, can you find this z-value that matches? So take a minute and see what you can do. Table or calculator. Now, I know some of us are hunting through our table right now, looking for 0.0300. Does our table give us the area, though, to the right of the z-value? No, it doesn't. Will the calculator accept the area to the right of the z-value and give us what we want? It won't. So if you're hunting through your table or if you're using your calculator, I'm not going to concern myself with 0.03. What am I going to concern myself with? I need this area. That's the area I need. Now, if you're using the table, guys, get as close as you can. If you're using the table, the closest you're going to get in table E is 0.9699. That's the closest you're going to get. The z-value that matches that is 1.88. So keep in mind, the table gives you areas to the left of your z-value. So you might need to subtract from 1 to get the area you're looking for. Also, this table's not perfect. It only goes out to the nearest hundredths for z-values. So go as close as you can. All right. So here's what we have. We know our mean, we know our standard deviation, and we know z. Now we want to find x. You don't need a new formula, folks. Let's put in the pieces that we know. We know z is 1. Z is 1.88. So 1.88 equals, we don't know x, minus our mean, divided by our standard deviation. We don't need a different formula. We're just looking for a different piece. Earlier we were trying to find z. Now we're trying to find the x part. So how would I possibly go about solving this? What's my first step? What am I going to do? Multiply by 100. Yeah, we got to get the 100 out of there. Multiply both sides by 100. That gets the 100 out of the denominator. So now we have 188 equals x minus 400. Easy last step. Just add our 400, yeah. Add 400. So we have 588 equals x. So the lowest score that I can get and be in the top 3% is a score of 588. This is all I'm looking for. I'm done. Unless they give you some kind of specific unit you really can't label. That's the score you need to be in the top 3%. That score or higher. Now for part B, we have the bottom 1.5%. They have to go to summer school. So if you're in the bottom 1.5% taking this test, you have to go to summer school. So what's the minimum score you need to stay out of that group? So let's write down again the information that we know right away. The mean hasn't changed. Standard deviation hasn't changed. We don't know z, and we don't know our score, so we don't know the x. What we do know, though, is we're looking at the bottom 1.5%. So the bottom is going to be over here in this left tail. This area, 1.5%, will be 0.015. Now here's the nice part. We're looking at the bottom, so we have the area to the left. So I don't have to do anything special. I'm either going to hunt around the body of table E and find that value, or I'm going to enter that value into my calculator. I don't have to do anything special. I have the area to the left. So take a minute and see if you can go ahead and find z. If you need some help, guys, looking at the table or with the calculator, let me know. All right, so what did you guys find for your z-score? Negative what? 2.17. Calculator or table? Like I said, in the table, get as close as you can. Pick the value closest, and that's what you go with. So now that we know z, now we can find our x. Now we can find that score that we need. So we fill in z equals our value that we don't know minus our mean divided by our standard deviation. Just be very, very careful, please. Some of us, I know, are big-time memorizers. It's not going to be multiplied by 100 every time, guys. The only reason it's 100 is because that's our standard deviation. So make sure that you are putting in the numbers from the question, the values from the problem, not from the example. It's not 100 every time. That's just this problem situation. It's a very convenient number, but it's not always going to be 100. Now, here's where we have to be careful. Here's where we have to be careful. A score of 183, does that get us out of the bottom 1.5%? What do I have to score to stay out of it? 184. So to stay out of the bottom half, we have to have a score of 184. So again, it's just one of those things where we need to make sure that we're not just, I'm going to do the same procedure every time. We need to make sure that we're actually answering the question. So are you being asked for a probability? Are you being asked for a percent? Are you being asked for a specific number of things? You need to make sure, a lot of the questions you're going to set up very similarly. The process is the same, but what you're trying to find might vary from question to question. So just be very careful. Just be very careful on those things as you work.